Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. Today we are going to go continue what we started yesterday. We are now moving back. We kind of have a sort in place that we liked and that we think is reasonable. We'll probably have to maybe play with it a little bit as we go forwards, but we need to kind of come back now to the sort of the final pass on Z handling in the renderer. And in order to do that, we kind of sketched out some stuff that we need to do. And it's probably going to be our job for next week. But, I mean, there's no sense wasting a day, so we should get started on it as much as possible. Yesterday, we kind of started playing around with it. And today, I think we can start making some headway in and put ourselves in a good position to get it done next week. Like I said, there isn't anything magical that's about to happen. Really, all we're doing is now going through, now that we definitively know how we want to handle Z, because we kind of had to experiment to figure out what we really wanted, because there's an art style issues, there's code issues, there's a lot of factors that went into deciding how Z really should work and what we wanted Z to do. And so now that we do actually have a coherent idea of what Z should do, we have to go through and make sure that we just do a certain amount of cleaning for how that pipeline looks, because otherwise we're going to start building everything on top of kind of a frail and janky system of how Z was being handled before. So that's really what I want to get to, is a place where we're starting to feel confident about our use of Z through the renderer, where there aren't a lot of gotchas or why did that do what it did. We want to be at a place where we're like, okay, we have a coherent idea of how we specify Z, and off we go. Because for those of you who have watched the stream since the beginning, you know that there's been a lot of times when we were like, what should Z do? Okay, have Z stop doing that. Okay, Z now looks at this and not that. And it's just, you don't want that to be left in the game, right? It's fine to go through those learning stages where you kind of go like, okay, this is a little weird right now, but we're trying to figure out how it works. That's all fine, but you want to make sure that once you have a coherent plan for how something's supposed to work, you can get it down to a place where you're not constantly having to second guess it or anything like that. So I'm going to go ahead and get started. Today is day 314, as it says at the bottom. So you're going to want to start with day 313 source code if you are in the mood to follow along at home. All right. So let's see here. Here's where we were at yesterday, and if you remember, we were sort of working on, we want, the next sort of thing that we wanted to make sure that we got right was when we look at what happens here with these stairs, we can sort of see that the stairwell up that kind of goes up here, not all the stairs are properly included with the bottom level, right? And part of that is because we're not actually coherently tracking Z throughout the, I guess for lack of a better term, the way in which we treat Z. We're not actually computing it in a way that looks at what chunk you're in. Because what we sort of decided was, all right, we want our Z chunks to line up with each individual floor, so everything on one floor is in one chunk, because obviously they're going to get pulled in together in that case. And so then what we wanted to do was say, well, the Z of the chunk should also be the Z that the renderer uses. So basically, like the chunks, each chunk Z, each single Z chunk is passed as a slice to the renderer. But in the actual render output as we are using it currently, we never actually had those values happen. And so that's the first thing that we wanted to do. And then the next thing that we want to do is, as you can see, like we said yesterday, we need to start passing these slices to the renderer as separate slices, because right now they're all mixed together. And they just rely on the sort rule currently to sort it out, which, as we know, we didn't write to handle multiple layers like that, because it's not supposed to be going through there. So that's what we need to do. So first we're going to try and get the chunks, the things aligned for the chunks properly. And then we're going to move from there to trying to get the renderer to think about these layers in a coherent way so that it's known in the sorting system exactly how they work. All right. So here we are in entity.cpp. And convert to layer relative is what we were actually using before in order to figure out where things were in Z. And what I wanted to do, and I think we put a little to do in here to this effect. So it says here, it's the chunk Z difference that tells us what the relative layer is, and we no longer care about the camera Z delta because things inside a layer aren't transformed prospectively anymore. So you can see that like this convert to layer relative bit, we don't actually want to deal with this anymore, right? That's not what we want. What we want to do is start looking at the chunk Z, and you can see we wrote it here, we wrote it out, what the relative layer values actually should be. Now, we have a problem, obviously, that we don't actually know what the new chunk Z is for a individual entity yet, right? Because this world position value isn't actually going to exist, because in the sim region, we've moved the person, and we need to know what their chunk Z will be once we go to repack them, right? Once we go to condense everything down. Then we could look to see what the, the chunk Z difference was here. Let's go ahead and get that out of there. So at that point, yes, we could. But we're not there yet, right? We don't actually know what, we don't have a coherent plan for what that actually entails. So what we have to do is take a look over at sim region, and in fact, we could probably also say, and I don't actually remember this part of the code too well, because it's been a long time since we touched it, but when we actually go to pack things, when we do pack entity into world, I believe that it's sort of expected that, it's, yeah, you can see it passing the world position here. So I believe that what actually occurs is when we do nsim, there we go. When we do an nsim, and everyone's getting pushed back, you can see that we have this concept of pack entity into world taking the chunk P. Now, the chunk P is something that only gets computed in here. So you can see it happening here where it does map entity to chunk space. So even though it pains me a little to do this twice, at the moment I don't know that we have a lot of other options. We could just store it in the entity and use it again. So, I'll put a to-do for that if we want to take a look at that in the future. But that's essentially all we're really talking about here. So if we want to know what the entity P would be for the chunk Z or whatever, and to be fair, we don't even really need to keep the result of this. We could just do, entity chunk Z, and when we do map and chunk space. Although, the way I think about it, we're probably going to want to know that offset. So I'm gonna keep the full thing around. So if I do world position, and maybe I'll just call it world pose for now. I do that map into chunk space, and now I actually have what I would need for the relative layer, right? I've got in here an updated value, meaning after the physics step for this, after this entity is moved, I now know what their relative layer is based on that operation. Now, once I do that, I will have the relative layer probably correct, but now I also need to think a little bit about the rest of the stuff that we need to do with this entity. Because you can kind of see in here where we're doing our sort of our output, we still need to have the entity transform set up to transform things such that they get displaced in Z in the right way, So we still do actually need a little more information. Where this chunk, where the entity is going to get drawn is gonna matter. And so we still have a little bit of work to do there. Now I'm going to leave that for now because we don't have any of the rest of the stuff in place for it anyway. But I just wanted to point out that that's kind of where we have to start going next. Apparently we don't have the world struct in here at the moment. Is that true? That seems weird. It's probably just world mode world, though. Like, we probably have it. We just didn't dereference it. It's probably just that, right? But I guess nobody else was using it. Or people who were using it, didn't bother to dereference it into a local. So now we can kind of see, all right, we're in much better shape now. We got our stairwell sorted so that all of it sorts exactly where we expect. And so now we're finally getting the part where these floors are a little more coherent, right? We still have the problem of we're not slicing them up, so we still have that error happening. But at least now we've got that first pass of things that are supposed to be on a particular floor are actually on that floor. And that's good. That's what we want. Okay, so the next thing that we need to do is now we need to start getting a little more serious about the other part of our Z transform. And this is where things are going to start to get hairy for us. So we need to, this is why we need to start tightening down and have a really clear conceptualization of what's supposed to happen. Because in order to get to the next step, we need to have a concept in the renderer of the layer Z and the actual Z value, right? Because the layer Z, basically that chunk dim Z, that value, is now something that needs to be known to the renderer for like an absolute sorting criteria, right? Now we can hack that in temporarily, and I don't know if maybe this is the way we'll actually want to do it in the end, I don't know. But we can hack that in temporarily by having the concept of the Z layer baked directly into the sort key, right? That's something we could do. And so, we probably want to simplify that sort key eventually because it's just a very bulky, there's a lot of sort of work going on in that sort key now, which maybe isn't the best thing in the world. So I don't want to suggest that we can just keep throwing things in here ad infinitum and never end up having to pay the piper. But at the moment, as we are working out how these things are going to come together, certainly that is one thing we could do, right? We could have it so that the sort breaks these things back apart. Now, in the eventual version of the final render pass, it may be that we have to be smarter about how things work than that. It may be that we want to break things up into separate buffers, instead of sorting after the fact. I don't know. But for right now, since we already have the sort in place, I'm going to propose that we just do something here that's like an uber op that's like chunk Z. And, chunk Z would be a thing that always demands priority in the sort, even above manual sorting. So it's like, this is a thing that's just, it's totally takes people out of the sort and moves them into, like, basically, it's like a group, if you will, of sorting. And so when we do that, and we go to do the test for is in front of, right? All we have to do there is first say that the result, whatever the result is that we're going to do, we basically add one more case here. You can see why I say we may have to get a little bit more smart about this, because you can just see this is a very complicated thing that's starting to go on here. And that's every time we compare two people we're doing. There's just a lot of fussing, right? And so, it makes me a little nervous. Does it mean we're actually gonna have to deal with it? I don't know, we're gonna see as we go forwards. Obviously, we'll find out. This isn't a game about having hundreds of thousands of sprites on the screen, so at that point, we kind of get a little bit of a free pass. That is true. But, just the point of it is that as things get more complex and like this, they start to like kind of trigger on my radar of like, well, this could be a problem. Doesn't matter right now, so it's fine, but it's just worth noting when things happen to you just want to be aware of where your possible trouble points are. You don't usually want to have them take you completely by surprise. So we could say here that if A chunk Z is not equal to B chunk Z, then we could basically just say that, well, if A is going to be in front of B, then A should have a higher Z value, right? So A chunk Z greater than B chunk Z would be the result. And that way, the chunk Z is sort of always specified excuse me, as a layering operation on top of everything else, which means that we can sort of feel free to group stuff into those sort of broad categories, if that makes sense. And again, for the render group, this is not a particularly hard, like these are, when I say that these are things that trouble me a little, I'm not talking about code architecture-wise. They're very, very simple and not difficult at all. I'm talking more about sort of the overall notion that I worry about, you know, what the cost will be in the end for certain things. Not worry like we shouldn't do it, but more worry about like, well, in the back of my mind, I think we might have to revisit this and do something better for the final version if we find it's too slow. So all I'm doing here is for manual sort. Oops. I'm just going to go ahead and make sure I see what's going on. Yeah, so basically the only thing I have to do here is just say, well, sprite bound chunk z equals object transform chunk z. And I think that's really it. So in theory now, that shouldn't affect anything because we're not setting it to anything. So when we come up here, we should see, oops, I kind of went the wrong way around there. We should see exactly the same weird sorting, and we do. And so now the question is, well, what would happen, and I guess we can sort of maybe see this live if we want to, what'll happen if I go ahead and change that that render code so that we actually do set the sort key in entity, right? Because we sort of have the manual sort part, manual sort. If we say entity transform chunk z equals world post chunk z, now we sort of have this automatic sort that's gonna kick in for that. So once I've done that, you can now kind of see how it works, and we do get z sorting there kind of for free. You can see how everything's sort of nice aligned, but we do have potentially one problem of that. I guess I don't know offhand. I'll have to think about to what extent it actually is a problem. Maybe it's not really a problem. I don't know. We'll see what happens in the final version. But the thing that I was noticing that was a problem was when I actually go up these stairs here, like so. I also wonder, why is there no alpha on the... Oh, right, because I didn't set the entity alpha. Right, that's yeah, never mind, set for sure. When I'm standing on the stairs here, I would like to see my guy be in front of the top piece here. And so what we may, I might say, though, that that's not really a problem we're going to have to solve that way. What we could definitely decide to do here is just once the hero is up on that stair, they move to the next chunk up, right? They're at a point where that's a reasonable thing to do or something. So that looks pretty reasonable. So what I would like to do here is I want to see too what happens if I expand out those bounds a little bit. To be honest, I don't really remember all that much how we were drawing those. I don't even know who is drawing those traversables. It looks like, is it this code right here? Yeah. So if I wanted to draw those a little bit more like actual tiles, right? I guess now we can kind of see what's happening in terms of like what this might actually look like in an actual game, right? As I sort of go through. It looks like we're getting some, again, sorting flicker there up, which I'm not really sure what that come from. I almost guarantee you that's cycle problems again, but let me see. Let me make sure that's actually true. Oh, we should probably all go put the debug stuff in a separate chunk now too, so that it would be on top for since we wanted to fix that bug as well. Let's see here. Yeah, and you can kind of see you get some nasty cycling going on there. I think that's just one of those things where, if you sort of overlap, the fact that we're doing overlap testing in such a broad sense, I think we get kind of a lot of unnecessary tiling. Like, these things don't really overlap significantly, yet we get sort of that thing. And I almost wonder if we shouldn't shrink things a little before we do our overlap testing. I feel like that would be a positive improvement because we don't really need to sort things that only barely overlap. You know what I mean? At least I feel like that would be true. How did I get those things to flicker? I know I was getting some tree flicker there, but I can't seem to get it to happen again. Maybe I was down a little lower. There it is. And you can see there's just tons of cycles. Like, everything is a cycle at that point. You know what I mean? Surprising the sort holds up as well as it does when there's so many cycles. So I'm curious, in the sort, when we do this sort of overlap test, right? And we do rectangles intersect, I'm kind of interested to know whether that rectangle intersection code, whether that would, what that would end up doing if I did like an add radius 2 with some shrink. Right, so if we had something like this, and we were to say that we wanted to shrink something, 4 pixels or something like this, I'm just curious. Oh, and I forgot, that's actually not in, that's in the platform-specific part of the code, so. All right. So let's say that we shrink, we shrinked things a little bit here. And I guess, you know what, I should probably also go do that thing so we can use our debug system again. Now that we have the ability to stack it in there, I'm just gonna say like, hey, all of these transforms, let's also make all of these transforms, oops. Let's, instead of doing, in fact, I don't even know if sort bias needs to be there anymore. I think sort bias may not have to be there anymore. Right? Because I think now we can just make chunk Z. Chunk Z is now our sort bias, and I think sort bias is completely useless. Because why would you ever use it when you have actual sorting happening? It was kind of a wasty sort of thing. In fact, let's just see what happens if we get rid of sort bias entirely. Sort bias. Oops, not soft bias. Group. There we go. All right, so get rid of the sort bias entirely, and off we go. All right, so let's see if that helps too with our debug overlay. Much nicer. So now on here, I'm going to go ahead and turn on those groups. And you can see how much nicer that is when we don't count things that are just barely abutting, because we don't really want the sorter to have to deal with that. There's not a lot of reason for it to deal with that, right? So, I'm pretty happy about that. And that also fixes our flicker. So, we do kind of now know that we probably want to break cycles a little bit more intelligently. And we kind of had a feeling that was going to be the case. But, I'm pretty happy about that. Where that's at the moment anyway. So yeah, so if we kind of, excuse me, sir, excuse me. If we see how that looks, I'm pretty okay with that alpha-ing in and out as well. But yeah. So the next thing we have to do too is, this stuff is illegal as well, so before we get too much further down there, we're also going to have to deal with the fact that these are not supposed to be skew in X, because that breaks our sort criteria as well. All right, so it seems like we're okay so far. Yeah, everything looks reasonable here. I think, are we allowed to jump down? No, we're not. It always picks a square that's like not too far down, it looks like. All right, so that all seems reasonable. And we mostly just have problems with those guys. That all seems reasonable. Wow. So now let's see. With the chunk Z in there, and having that slicing everyone into groups, at this point we're sort of doing, I guess we don't really have a way to leverage any of this stuff in the actual renderer, and that's kind of the problematic part, right? So we had those clip recs. We had clip recs in there, and we had the notion that we could associate things with different clip recs. So we do kind of know some of the information about what we need to do, but unfortunately, it's kind of a little all tangled up, because what we're going to want to do, right, is we want to be able to draw the stuff that's in the alpha group all into like a separate buffer and then blit it on top. That's kind of, it requires the renderer knowing more than it knows right now about what's going on. You know what I mean? But what we could say at the moment is that our fog, we could re-enable our fog properly and not really have to push that through to the renderer. So I feel like we're kind of at a position here where we should sort of extricate a little bit of what's going on from the renderer. Let me see if I can give a little bit more concrete explanation. But basically at the top, when we're going to do entity rendering, and we come through here, we do this sort of, we build these sets of levels that's what are the effects for each level that we want to have, right? And so each level has something like, okay, you know, we're going to do a particular background color blend or something or whatever. And so what we're really talking about here is the fact that we don't really need to treat this as, we don't really need what we're getting here, right? Because we're actually treating this like we need the renderer to understand that we have 7 levels or whatever, I don't know, 5 levels, 6 levels, however many we have there, -4, -3, -2, -1, 0, and 1. So it's actually going to be 6 levels. We have 6 levels, and really it only needs to know about 2 things. It needs to know about the alpha one and everything else. And so most of this is for our benefit. Most of this is just for the fog, right? And so if we took that out and just handled the fogging ourselves, that would be nicer, because then what we have to change in the render is more minimal. It's just, are you in the alpha fade layer and how much alpha fade is happening in that layer, or are you not? So, let's start by doing that. And the way that I'd like to do that is say, like, okay, you know, maybe we just do fog amount or something like this. And you can see in here where we sort of are doing the fog amount computation, you can see that happening here. Here's the fade, you know, topsy stuff. This is the stuff for actually alphaing out, if that makes sense. So what we could really do here instead is just say, like, oh, yeah, we don't need a clip rect for any of this stuff. In fact, we don't really need to be creating these clip rects at all, probably. We probably just need, if anything, 1 clip rect if we want to associate, or maybe 2 clip rects, 1 for the stuff that's in that alpha layer and 1 for the stuff that's not in that alpha layer. So we could do that. Now, the only thing about that is we don't really process things by their clip rect layer at all. So I'm actually thinking probably I just want to nix that whole concept. I don't think we need it, and we'll see why. So I think that was just a bad idea on my part. It was like a thing that we tried. I don't like it, and I don't think we're going to use it. So I'm just going to pull that out now so we don't have it sitting around anymore. All right. So let's take a look inside the clip rect structure. You can see the clip rect effects thing. I don't want that anymore. I don't really want any of this at all. So I'm just going to recompile without that. and I'm going to see who ends up having a problem with it. So there's us pushing the FX. When the FX actually happens, I don't know that anyone was even using it. Let's see, and everything else is in render entity. So for render fog amount, we know that we've got this many. I'm going to get rid of that, and for now I'm going to leave the test alpha in, even though we're probably going to yank that in a minute here. So when we come through here, I'm going to say get rid of the clip effects, get rid of all the clip rect nonsense that was happening. We don't need any of it. It's not relevant. And then I'm going to say, like, okay, we'll just assume that the test alpha is 1 for whatever this layer is. And we'll assume that the fog amount is also set to a prescribed value, in this case 0. We'll say that fog 0 means you're not fogged at all, and fog 1 means you're completely fogged. So then when we come in here and we do our clamp map to range, really all we're doing is saying, well, okay, our alpha is always going to be 1 unless it turns out to be... oh, well, actually, it may be that you can just always do this. Can I just always do clamp map to range? I think I probably could. Because if you have gone off one end, you'll just always be back at 1, right? And so I feel like that's probably just fine. And the same is probably true here, I would wager. So we can probably just do that. Everything can be computed just fine at that point, and then we don't have to deal with any of this, this nonsense here. Now, for test alpha, I feel like it was going the wrong way because we were doing a 1 minus there. So if we want to know what the alpha value is rather than the fade amount, we can just invert this and we'll get a reversed range. So I think that's roughly what we need. Let's take fog amount there. There we go. And fog amount. Okay. So down at the end here, render group current clip rect index is not going to get modified anymore. So we're just going to use the default clipping rectangle at this point. And now we're at, I think we're at a place where everything should be working as before, but now we just don't have any of those clip recs, right? All of that stuff is not happening anymore. So now I should be able to actually set the entity color blend value. And that color blend value, excuse me, that color blend value is going to affect everything that we draw. So what we were doing right now is we were kind of doing that manually. I don't know if we want to do it manually or not. You know, maybe we do, maybe we don't. I'm not sure, but you can see what's happening here. But that's also, you know, the fact that we're doing it manually has some downsides. It means that it's a little confusing sometimes what's going to happen. So maybe we want to make that be a property of the transform, so when the colors get rectified, like this is sort of how we had it a little bit before, maybe that kicks in at that point. So let's go ahead and try that out. Just see what we've got here. There we go. Where's that alpha value? There it is. So this is piece colors. That doesn't have to happen anymore, so I think we're all good. Okay. So now that I've turned that off, now we're going to see those bits above us, right? They haven't alphaed out to 0 yet. And so now what we need to do is we need to kind of go back into the render group and sort of, I think I kind of had it this way before a little bit. When we rectify a color, which is something that we had before, where do we do that? It's in here somewhere. When we do a store color, you can actually see we've got sort of the global color thing happening here, right? And so I think we can do, we left in actually the exact stuff we need. So I think we can do everything that we want here. Now my only question is, when we do the store color, could we have not gotten that from the object transform? Like I kind of feel like we kind of want that to be object transform specific. So I feel like, you know, that's better than having a global value that sets on and off, because we already have this notion that the object transform is kind of the thing that stores that transient state. So I'd rather, you know, if we could, I'd rather have it look more like this, where we do the store color, rather than ever having those global values. Let's see, that store color, there we go. If you look at what actually needs to happen here, right, I can just do a thing where I say like, okay, object transform, transform, and I don't know if that's a pointer or something like this. And then transform, transform. In there, I now have the ability to sort of specify that on a per transform basis rather than a global basis, which I think I like better. So here we are on the object transform. There we go. And I don't really know. So these get passed around. And if they actually get inlined, I suppose that's fine. I think the compiler will be smart enough to do that, right? But otherwise, we might want to start passing those because they're pretty big by pointer. So I'm not really sure about that. I kind of feel like we might want to start passing pointers to the object transform rather than saying the object transform itself. So I might suggest moving in that direction a little bit based on the size of those. So okay, let's go back over here and clean that out a bit. There we go. Make these into pointers everywhere. There we go. And get render entity basis P. And let's see. Yeah, because I don't really know if the compiler, what the compiler is and isn't smart enough to do there. It's been a long time since I really sat down and looked at what the compiler does for code. And so I feel like my knowledge about what the best thing is to do, especially for debug code, like sometimes I'll do things even if the global, even if the optimizer would have done it fine. Sometimes I still like to do it manually if I can, just because I don't want to have my debug builds be slow, you know? Because I like to be able to step through code cleanly without having to deal with all the sort of crap where the debugger can't inspect values and doesn't know what's going on all the time. So, you know, to a certain extent, there is a lot of that. But anyway. So let's take a look here. I'm just sort of pushing this through. There we go. And this is not a particularly interesting thing at all. This is just busy work, right? Busy work that our tools should do it for us these days. Of course they don't. Why would they? We've only had 50 years of programming tools. You know, let's not get too excited. Okay, so yeah, anywhere here where we were doing transforms, let's just go ahead and keep passing that through. So in here we would do an address of an entity transform. Same with here. And here we go. Keep it coming. Keep it coming. And I don't think this needs to do anything now, because now we don't have that nasty global making things scrappy. Let's see. So default flat transform. I don't know if we're allowed to pass that. That was one of the nice things about it, is you could just call it in line, but that's okay. I don't know. How often we were really taking advantage of that anyway, though. Let's see here. So, where are we? We are in render layered scene, and so, okay, so we're gonna just have to take the address of that transform. Address of, transform. Flat. I suspect some of these probably don't really want to be just the flat transform, but who knows. So no transform, just pass the address of. we go. Oddly enough, most of this stuff is in the debug system. And UI transform, UI transform. There we go. And hopefully we're getting towards the end. Not that this isn't so exciting. In theory, this is a computer, yes? If only there was a machine that was good at doing repetitive tasks. All right. Hopefully everything's still fine. There we go. And so now, in theory, all of our stuff is actually working properly through the pipeline with that color as well, which is what we initially did. And so now I should be able to set those values and per entity when I do the transform and have them do what they need to do. So in theory, again, only in theory, I should be able to set entity transform color and entity transform key color in this case. Now, what we know is that the fog value, it's dependent on what relative layer you're in, certainly. So what we need to do here is say, well, if the relative layer equals the maximum level index, then we've got the alpha, otherwise we don't, right? So we essentially have two separate things we're going to do here. So in the case we're at the maximum level index, what we want to do here is create a T color value that's only affecting the alpha. And it is going to blend. In fact, I don't think we even need to set the color to anything. But in the other case, we do need to set the blend to color to be the background color. And we need to set the T color to be whatever the fog amount is for this layer, right? So as we can make life a little easier on ourselves like this. There we go. And so I'll pull out that fog amount, and that's just going to be, in the first portion, and we're not going to affect the alpha at all, right? So at that point, I think we're good. And so when those colors get stored by the renderer now, in theory, they should be working. Of course, I'm not seeing that happen. And I would like to set a breakpoint, please. There we go. There we go. So when I set that T color, that should actually... Oh, no, default upright transform. It would set everything to 0, correct? I think I might have to go in there and initialize those, because actually, now that I think about it, that might not clear them. I don't really remember what it does by default. So let's see. T color, color, and T color. Well, actually, it looks like our problem is more that our T value, our test alpha value, doesn't actually... Oh, right. Now we're back to being inverted. So this test alpha value here is actually now back to the old way it was. So that's actually what's going on there. Okay. So there's our color happening inside the renderer now. We come up here, and that all looks fine. So that's good. And now we should see whether or not we can get fog. We might have to create another layer for fog. Now you can actually already see the fog happening. So let's create some more layers just so we can get up a little higher and see more fog just to make sure what's happening is get down there. But I think that's now a reasonable situation. Okay, so that is just going to be inside world mode. And when I do my add standard room, and I just put, a bunch of rooms on top of each other, Hopefully that all works. So yeah. And also you'll note that as we put more rooms on top of each other, I believe we'll see... oh, that's interesting. Huh. I was going to say, I thought Build Sprites was the only thing, but Get Close Traversable is also one that doesn't use a spatial partition currently. Build Sprite Graph has a lot of stress on it right now, and so we kind of know that that guy has just has a lot of issues in debug mode. I would be curious to know how he's doing in optimized. I'm just going to take a quick check. It's quite fast, so yeah. So, but it's still a little bit high. So yeah, it's still a little bit high. Our tooltips look like they're not on the right layer, which is interesting. Anyway, so that was again part of the thing where I was talking about before. I think we want to do some work to make a better situation for ourselves in terms of how we pass those things down and not have the sort have to deal with the layers. Oh my god, why are there so many heads following me? Jeez, that's creepy. All right, so the fog looks correct down there though, right? Which is all I really wanted to know. There's too many things happening on the screen right now in this game. Which is not my intention, but yeah. Okay, so that all looks pretty good down there. All right. So I think we're good. Okay, so now before we can really take a good look at our sort for reals, again, we still have one more thing at least that we have to do, which is start to get the Z handled correctly in terms of displacement from a layer, right? Because now we've got sort of two different concepts of the Z position of an entity, and that's a thing that's going to have to be dealt with. And we've got, what we've got 12 minutes, if that makes sense. Is that right? 12 minutes? Yeah, we've got 12 minutes to go. And so, yeah, I don't know how far we're going to be able to get in that, but that's roughly what we need to do. I also don't really know why we're getting some bleed through on the layers there. That's very odd, because in theory the layer is totally primal. You shouldn't be able to ever see anything through it. But there's some like peeking through of the health rectangles there, which is odd, right? So we may have some bugs in there, because that's... Oh, but you know what? No, that's not true. Because we put all of those things into the graph, which I really didn't want to do. So actually, if there are cycles, you could even get a bug there, right? So yeah, so I think that really does argue for what I was saying before, is where like we have to do, we're going to have to segment these things up into those different passes. I think that's definitely going to have to occur. But, you know, we've got some tricks for that. I don't think that's the end of the world, if that makes sense. And there's also some things we can do. One of the things that's a little bit janky is that it would be pretty great. It would be really, really nice if we could always ensure that, you know, if we always rendered everyone with the chunk Z they started with at the beginning of the simulation, instead of the chunk Z they end with, if that makes sense. And the reason for that is since we happen to stream the entities in, and we gather them based on chunks to begin with, all of the entities are already in sorted order if we want them to be in the sim region. So we would literally not have to do any work there if we could just count on that, right? But of course, you know, when somebody is moving between two regions, it would be wrong for one frame. I don't know how big of a deal that is. I think I might like that fact so much that it feels like we probably would want to still do it anyway. Yeah, I mean, that kind of feels good to me. I'll be honest. That feels like something that feels like if you used it, you would. It's just kind of too cool to not have that happen. And I wish we could do the same thing for the screen space sorting, but again, that one's going to be too visible of a bug, I think, if you actually did that. That's just my assumption. So I think I'm going to take a look at that before we go and do the Z thing then. So here's a proposal for you, and maybe I guess one thing that I could do is just explain it and not start it till tomorrow, but I mean not start till next week. So let me just kind of give you what I was sort of thinking here. What I was thinking of doing for this is saying, well, we've got these slices. It would be great if what we could do is make it so those slices are essentially like coming out in the buffer, in the render buffer, in order, roughly. And in between each layer, there would just be a barrier token, like a thing that basically says like, hey, sort everything here, but don't include the stuff that comes after it, right? So that we're only sorting in like buckets, right? And then if you put all of your entities out in order like that, then you wouldn't have this problem. So, for example, if we go over to the sort, where we do sort entries, right? I think, although I don't actually know, I think if we just make this be a for I loop that basically like goes through and says, oh, you know, when I do the build sprite graph, I walk through the nodes, right? And when I hit one of these nodes, you know, when I hit a node that's got a special key in it, I know that that's a barrier, and I just stop, do the sort, and then continue, right? So it'd be something like inside the sort sprite bound, you know, maybe we just take that that manual key, and maybe the manual key just has a special code in it, right? So there's maybe like a thing that's like, you know, sprite barrier value or something like that, and maybe the sprite barrier value, you know, is some puffy value. So you know, it'd be something like, okay, you're kind of coming through here until you get to the input node count, and let me see what we've actually got here. Input node count and node index. Yeah. Yes. So I think So I think all we have to do here is, instead of making this be 0 to input node count, we would really just take in a value that was what the node index was that we were going to start with, right? So we'd almost just say like, oh, okay, you know, whatever one we're going to start with, you tell us. And when we're doing the build sprite graph, we would just say like, oh, okay, you know, do a for I loop outside, where we say, hey, there's a node index, or like, you know, first index or something, that's going to equal 0. Assume that we run until first index is less than whatever the count is, and we don't increment it at all, actually. We pass that to build sprite graph. And we get it back as well. So inside build sprite graph, we can return a value here that is whatever node index A actually turns out to be when it's done. And we can even do the test here. We could say oh, okay, so in the test, we'll do something where we say if we hit the sort barrier, stop, right? So do something like if a manual dot, what is the, I don't remember what this is here. If a manual foo equals the sprite barrier value, then we bail. And that's it, right? Not a member of sort sprite bound. Is that so? It's in here actually. So I guess in that case, if it's actually in here, if this is what we're looping over, we could actually, it actually wouldn't have to be stored in the manual part, I suppose. We could store that in the offset instead. So maybe we'll do that. So in here, we'll do sprite barrier offset value. And we'll say, okay, so a manual.offset is not right. We just want offset, and that's it. So if we run it now, because we're basically out of time, we shouldn't have any change, so everything should be fine. But now we should be able to go back and make that change, which I think is what I'd like to do on Monday. I'm going to go to build.bat and say that we're going back to debug mode. And then I think we're going to call it for tonight, because I don't want to start that until then. And I think we'll also get our frame rate back at that point, because right now it's a complete crazy town, right? Like if you look at what happens with the, right now there's just, everything is just nuts in terms of how much stuff there is getting sorted and whatnot. And there's really no need to create these ridiculous graphs. They're just, and they're going to create all kinds of cycle problems for us as well. Yeah. All right. All right, let's go to the Q&A. Biblo, where are all those familiars coming from? I have no idea. I mean, there's one familiar created for every level, and I guess, I don't know that, I've looked at the familiar code in a while, I don't know that they might just be able to, yeah, I think that they're allowed to just go straight line a little bit, I guess. I don't really know. So I think they just kind of can float on down. Their code is such that they don't, I don't think they check for anything other than whether the thing they're going to is blocked. Those things are creepy. So I don't think there's any questions. Which I guess means we can end early. The snake looks broken. Yeah, I guess why is there only one piece of the snake? The snake was like, went up the stairs or something. How was it allowed to do that? That's a pretty interesting bug. Snake, how did you do that? It went up, not even the stairs, it just went up to a higher level. But only that snake. All the rest of the snakes are apparently fine. That's real weird. I also don't think we've ever seen that before. Have we? Oops. It's going to be nice to finally be on game code after all, so I can go make all this stuff a lot tighter and cleaner than it is. It's also kind of stupid now, since we haven't really written any actual game code here. Like, guys, seriously? Come on, get out of there. I'm trying to go up the stairs. Just come on over here for a second. And just stay out of my way, please. Oh, now the snake is okay, that time the snake actually decided to go up the stairs, which I suppose is fine, as long as it gets out of the way. So yes, somehow, and we will have to debug how. Oh wait, no, but that's the snake that just went up the stairs. So no, we still don't know where that other snake went. We have no idea. Okay, guys, stop going up the stairs. Where do you think you're going? Is there even another floor? I guess there is. This still does not answer our question as to where that first snake even went. We have no idea. So there it is. So somehow that guy jumped all the way to the top level. I'm assuming that we must have a bug, or because we haven't, well, I guess we didn't really do much on the code for, in fact, we haven't done anything, I guess, on the code for Z, like how far you can jump up. It must have done something interesting where it was able to pick a high floor right away. These are the creepiest. I tell you, dismembered heads floating around is just, it's just creepy. Yeah, I don't know where the snakehead actually is here. Unfortunately, I can't really look. Like I said, I'm not really too concerned about that code because that's not really stuff that we've kind of dealt with finally. It's just weird, some of the behaviors you get. All right, I'm gonna wrap it up. Okay, thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with a source code. We also have a forum site that you can use to ask questions, a Patreon page if you want to support our video series, a schedule bot that tweets the schedule at you if you want to know where we're going to be live, and an episode guide which will help you catch up on our past fine episodes. That's about it for tonight. I'll be back next week. Be sure to check the schedule bot if you want to know when. Until then, have fun coding, everyone, and I will see you on the internet. Take it easy, everyone.